Hey, everybody, and thanks for joining us. I'm Gray, the manager of the Lit team, and I'm happy to welcome you to the meetup. Today's topic is Lit Labs. We introduced Lit Labs last year when we released Lit 2, and since then we've actually been working on a number of Labs packages. In fact, that's where we've been doing a lot of our most interesting work. So some of the projects we've been working on are now nearly ready to graduate out of labs. And we've also been putting a bunch of thought into giving more structure to the labs process. So now seems like a good time for an update. So I'll start by briefly reviewing what Lit Labs is all about. I'll talk you through the process of discovering a labs project, trying it out, and giving us your feedback. And then I'll turn the stage over to the team to tell you about several of the current labs projects in more detail and let you know how you can help us move them through the pipeline. So if you have questions along the way, go ahead and just ask them in the YouTube chat, and we'll finish up with a Brady Bunch style Q&A at the end and answer as many of those questions as we can. So first, what exactly is Lit Labs and why does it exist? So as you know, the Lit library itself is intentionally very small and simple. It tries to give you just what you need to easily build great web components, offering broadly applicable features like reactivity and templating. But in a real-world project, depending on your use case, you may need to layer functionality on top of Lit. And we think this type of specialized functionality is best delivered in the form of what we'd call an add-on package. For example, Lit Localize is something that you might use in certain projects. As it happens, we have lots of ideas in general and for add-ons in particular, but it's sometimes hard to know in advance exactly what a given package might do, exactly how it should work, or whether it's even useful enough to become a full-fledged product. So Lit Labs is essentially a space for us to develop add-on packages in the open, explicitly inviting your input, your feedback, and your early usage. Now, as I mentioned, we've had a number of Labs packages in the works for a while, sort of since the start of Lit Labs. But we've done some work recently to formalize the pipeline and streamline the way we communicate about it. So I'm going to walk you through that pipeline now. Notably, I'm not going to start at the very beginning. We're going to come back at the end to sort of how a Labs project might get started. But for now, we're going to hop into the process at the point at which a package has been under development for a while. So from that point, here's how a Labs project will typically proceed. Once a package is ready for usage and feedback, we'll go ahead and publish it under the Lit Labs NPM org, and you can see a bunch of our current projects there. And at the same time, we'll also add it to the Lit Labs page on lit.dev. And you may have noticed, if you spend a lot of time hanging on lit.dev like we do, we recently updated this page so that it gives a much more thorough picture of what's going on in Labs. It gives an overview of Labs in general, but more interestingly, it also contains a list of all the projects that are currently in process. And on that page, these projects are grouped by phase. So you can gauge how stable a package is at any given point in time before making a decision to go ahead and use it on a project. So Labs packages, as compared to the core library, will tend to have more frequent breaking changes because, sort of by definition, we're still in the process of refining the feature set and the API. But we will follow SEMVer, so you'll know when a breaking change occurs. And in general, we want to encourage people to actually use these in real-world projects, as long as you are at a spot where you understand the status of the package and you're able to absorb the occasional breaking change at your own pace as those changes happen. So in addition to the Lit Labs page and publishing to NPM, we also have established a convention of creating a discussion page on GitHub Discussions for each individual Labs project. And there's a structured bit at the top, which will have some boilerplate about exactly what the status of the project is and a description of what it is. And it actually has a very informal sort of feedback mechanism where you can just use one of the reactions there to let us know whether this is something you're interested in, whether it's something you're dying to have tomorrow, or something that doesn't sound like something you need. And then, of course, like any GitHub discussion, you can ask more detailed questions, make suggestions, and we're happy to engage with you in that space. So once a Lit Labs package has been out there for a while, and we use this discussion format, plus, of course, you can come talk to us on Discord or on Twitter. we'll consider all the signals that we're getting. And once it crosses a certain bar of confidence for us in terms of usefulness and adoption, we'll make a choice to graduate it out of labs. And we'll communicate, about that as it happens. If on occasion the labs package, seems to have missed the mark, it doesn't look like it's paying for itself in terms of the amount of effort required based on the interest, we may decide to deprecate it and never graduate it out of labs. In that case, we'll always be sure to give at least 6-month notice before we stop supporting it and making bug fixes. And of course, because these are open source, we're not going to pull it down from Lit Labs, so you don't have to worry about the rug being pulled, completely out from under you. So that's roughly how the process works once a package comes into existence. And I just want to briefly talk about sort of what happens at the front end of that. So pretty much all the labs packages that are there now were ideas that originated, on or close to the team. But we envision this as being a situation where you, the lit community, may have ideas for great labs packages. And so separately but related to labs, we also recently introduced an RFC process. And we think that this RFC process is probably the best spot to sort of propose an idea for Lit Labs in a way that we can publicly discuss it and work out some of the goals before we actually start work on it. And with that being said, we're actually open to various models of engagement on this process. So for example, the context package, which Justin is going to talk about very soon, is actually one that, most of the work on that was done by an external contributor, Ben Delar from Adobe. And so we would actually love to see, that type of engagement on a bunch of other labs projects. So with that, let's move on and dive into specific talks. So I'm going to go ahead and remove my slides, and I'm going to invite Justin Fagnani. Welcome, Justin.
Hey, Gray. Excited to be here. All right. So, hello, everyone. I'm Justin, like Gray said, and I work mostly on the Lit core libraries. And the package I'm going to talk about today is the Lit Labs context package. So I'm going to go over some things, exactly what we mean by context, the package itself, and then some interesting things like the context protocol that this package is based on, and finally some use cases in a demo. So first, what do we mean by context? Context is a really general term. I think a lot of people in the front end web dev world will be familiar with its common usage these days, but not everyone. So let's give it a definition here. So I think the best definition I know of is that context is a way to provide data to an element tree without data binding. The data is contextual. It's just available without having to pass it around. So let's look at this in pictures. So here, imagine we have a component tree, and we have a value that is owned maybe at the root of this component tree that we want to make available down the tree. So we want any component further down in the tree to be able to get a reference to this value here. And so typically what you'll do with data binding is that in order to get this value from an ancestor to a descendant, you'll pass it down with data binding, which I've shown in these gray gray arrows here. And then finally, the component that needs a reference to it will have a strong reference to it there. And so let's look at what that looks like in code using just standard lit data binding. So first, we're going to name our elements here. We're going to talk about a root element, which has the value, a parent element, which is kind of in the middle of the tree, and then a child element, which needs the value. And so here we have our root element. We're going to implement this, and we're going to have this value foo here, which we want to pass around. So you can see that we have foo as a reactive property on the root. We're going to initialize that somehow. I won't show that here. And then we need to pass that down to the parent element. And this is the element in the middle of the tree. And then we have to implement the parent element. And in the parent element, we need a reactive property for foo so it can receive the binding, and then we need to pass it on to the child. And then finally, in the child, we need to have a reactive property on the child to receive that element. So you can see that every element in the middle of the tree, this parent element here, needs to have a value defined for this reactive property and to pass the value on. So we'd like to do something a little better than that, less boilerplate. So what context does is it says if you have a value available at the root of your tree, we're going to turn the element that owns that value into something we call a provider. And that provider is going to make it available to any element below it in the tree. And we're going to call those consumers. And they're just going to be able to kind of almost magically get access to that value. So now let's look at the package itself and how it helps us do this. So the context package gives you a few exports to let you provide and consume these context values. I'm going to show what I think are the 3 easiest ways to use it here. Create context, which lets you identify a context value, and then the context provider and context provided decorators. So if we want to use context, the first thing we need to do is create what we might call a context key. This is a way to identify the value that we want in case there are multiple values flowing through the context system. And then we can look at the root element here. And you can see that the difference is instead of defining a reactive property, we use the context provider decorator, and we use that context key here. And then we have our template, and we render our parent element, but we don't have to data bind into it. And next, you can see that the parent element doesn't have kind of anything to do with this context value. It doesn't know about it. It doesn't have a property for it. It doesn't have any data binding. And then finally, in the child element, we use this context provided decorator here, give it the same context key, and this will automatically get the value. Yeah, there. So this is what it looks like using context. We could kind of remove the parent element definition here because it doesn't really matter that much. And one additional thing you can do is you can subscribe to a context so that you can get all the changes so that everything is dynamic. And this way, if you set the roots value to the roots property to a new value, that'll automatically update. It'll update the context, and that will automatically update the child, and everything will stay in sync. So that's what using it looks like. You can install it here at the @labs/context package. And then the main things it gives you here are the 2 decorators that I talked about, context provider and context provided. And then we have these reactive controllers, which are kind of like the implementation detail of the decorators, which you can use directly. And then we have a thing called context root, which is a way of buffering and replaying context requests for lazy loading purposes. Okay, and so the context package is actually pretty straightforward and easy to use, like I showed there. Just add these decorators and basically just works. Some of the really interesting things about the context package, though, are how it works and the fact that it's based on a open community protocol that we call the context protocol. So this protocol is made under the Web Components community group. And this one was made by Ben Dallaire at Adobe, who contributed both the specification for the protocol and the context package itself. So thanks a lot, Ben. So you can go read it at the Web Components community group site. We'll drop a link somewhere in the metadata here. And the interesting thing about this protocol is how it enables interop and how it works. So I wanted to describe that a little bit. So the main thing that context uses is an event pattern for being able to request items from above you in the tree. So the way that system works is we'll have a consumer and it wants to get a value. So it'll fire an event, and that might look something like this. It's just going to use a standard API to dispatch an event from the DOM. And then we have an event subclass here called context request event. That's going to take our context key and a callback so that the value can be provided to the consumer. Remember, this is low level. This is kind of how the context package works under the hood. So that event is going to go up our tree, and it's going to get to the provider. And the provider is going to add a value into it. And the way that works is like this. So we're going to add an event listener to the provider for a context request event. It's going to stop propagation because it knows it can handle that context value, and it doesn't need to delegate further up the tree. And then it's going to call the callback on the event with the value that it has. And that's basically the entirety of the protocol there. It's pretty simple. Events are awesome for doing this kind of thing. If people don't know some of the details of how events work and why they're so suited for this, well, one, they bubble up the tree. And so we're trying to get values from above the tree, and that's great. They're also cancelable. You saw that stop propagation call. So an element can say, I have this value. My parents don't need to try to provide it. They're also synchronous, which is really important when you need a value and don't want to get it asynchronously. And they can have a custom API like that callback I showed on there. So that's the event-based protocol. It's interesting to think about how this is similar to and differs from framework features that are similar, especially Angular dependency injection and React context. So the first thing is that it's interoperable. Because it's based on an open protocol, this doesn't just work with Lit. You can use it with other libraries that might implement the context protocol. I think Fast has an implementation. Stencil might have an implementation. And also, you can see the protocol is very simple. So you could just do this in your own vanilla web components. It works with custom elements. This is kind of important and implied here, but custom elements don't have constructor arguments that you can rely on because the browser calls the constructor with no arguments. So we can't really do a traditional DI system like Angular has. So by working with events, we enable custom elements to have a dependency injection-like system. And also, the DOM is dynamic. Elements can be added and removed over time. They can be reparented. And so by working with events, you can fire them at any kind of time in the DOM if elements move or the ancestry changes. And so this protocol works with a dynamic DOM like we have. All right, let's talk about some use cases here. You can do some very interesting things with context. So the first is basically what I showed you, kind of ambient data. So using context allows you to eliminate what is often called prop drilling, which is having to set these data bindings up all the way down through your tree. And so if you have some very, very commonly needed data, like a user that's logged in, you can have a user context and then just get that in any component that needs it. Theming is an interesting case. Context behaves a little bit like CSS inheritance in that the values inherit down the tree. So for things that you can't do in CSS, like if your theming needed to include like extra templates or some JavaScript or something, you could have a theme provider provide these bits of behavior and style to components down the tree. Another interesting one is light DOM data flow. So some people have made projects where they want their users to be able to kind of construct UIs and interesting object graphs just with HTML. You know, for your light DOM children, we don't have data binding, right? Because they can come from any framework. So if the elements are interoperating over context, then the child elements can get data from their light DOM parent elements this way. So here you might have a page that provides a user and some kind of user display element that can display that regardless of what type of parent it's in. Similarly, a use case I really like is DOM-based plugins. So, you know, instead of just UI elements, you might be trying to make a declarative API or wrapper around a JavaScript library that is heavily plugin based. Well, it turns out if you provide the main API surface via context, you can make plugin elements. So you might have a text editor and you're able to add language support by dropping in language elements inside of it. Okay, so now let's hop over to the one demo I have, which will hopefully show how this works. So over here, I have a little setup with two containers. I call them number container. We have the one with the blue value in it right here and the red value. These are both context providers, and they're going to provide the value that's in the input right there. So if we look at the container, we can see that we use the context provider decorator here. We've created a number context, which we've imported from a shared module. And then we have an input that's simply going to set the value field that is decorated here. And then we have this display element here, and this uses the context provided decorator here. It uses the same shared number context, and we're going to subscribe to the value so we can get updates. So now if we go over to the demo side, you see we can enter a value, and when we change it, that value is going to show up where we're consuming the context value. And we can have more than one subtree with different values here, even though they share the same context key. Over here, we're going to provide the value 8. So that shows how you can get a value to a subtree, two different subtrees here. And we can also show how it updates because we're subscribing to the value. So we can do 1 over here, and we see that updates. And then also, because we request refresh of context values when elements move, I added a little bit of drag and drop here, and we can see if we move the blue box over here into this context tree, we're going to get that new context value 8 right there. So pretty easy to set up, and you get some very nice dynamic behavior there out of it. All right, to recap, like Gray mentioned, we have a standardized set of statuses. We think context is pretty close to GA. We have a known set of things we want to work on before we graduate it. There's a couple of places we want to double check alignment with the protocol. We have some ideas for simplifying the names a little bit. We want to work on SSR support, improve some TypeScript typings. We also want to do some benchmarking to make sure that this pattern is fast enough to use for pervasive things like themes, and finally get some documentation up. Specifically, we're looking feedback on a couple of issues. One is upgrades. So if you have lazy element upgrades, how often do you need to upgrade a consumer before a provider, asking for a value before it's available? So we have a solution for that called context root. We want to get some feedback on if it's good. The decorator names, they're a little bit long and they only differ by one letter, so they're kind of hard to differentiate. So what do we think about renaming them to maybe like provide and consume? And then also, we don't have the ability to provide data to separate sub-templates inside of an element, just like kind of an entire host element at a time. And we need to see if people really need that or if what we have right now is sufficient. So please try it out. You can install it with @litlabs/context, and then you can open issues or join the discussion at our GitHub repo lit/lit. And that's me. Thank you.
Awesome. Thank you, Justin. That was great. And another thank you to Ben Dallaire for doing all the work on that. I noticed he was already engaging on questions in the chat as we were talking. So we'll take all of the questions and answers at the end of the program, just FYI. So keep putting them in the chat, and then at the end, we'll all come up and talk. Thanks again, Justin. And next, I am going to invite onto the stage Augustine Kim. Welcome, Augustine.
Hey, thank you, Gray. Good to be here. Hello, everyone. My name is Augustine, and I'm an engineer on the Lit team. And I will be talking to you about SSR, or server-side rendering. So we'll look at an overview of Lit SSR, as well as what's new we've been working on, as well as the project's current status. Let's start with a little bit of an overview. So why would we want to care about server-side rendering? So one reason would be for performance and robustness. We can render static HTML without waiting for JavaScript to load, improving some performance metrics. And we can also do it for search engine optimization and web crawlers. While the Googlebot does actually support JavaScript, if you didn't know, not all web crawlers might do. So it's good to have. And also for project requirements. Customers for components built with Lit may have strict SSR requirements. We've actually been hearing a lot from the community that they wish to build a design system with Lit, but have strict SSR requirements from downstream consumers within their organization. So for these reasons, SSR is definitely on the top of our minds. Let's take a look at some highlights for the Labs SSR package. So firstly, it allows server rendering of Lit elements and templates to static HTML markup. We do actually consider this a low-level library, such that the API provided are intended to be used in creating higher-level integrations. Not to say that you can't use them directly. As you'll see in a little bit, we'll give a little demo. But we do anticipate most users to be taking advantage of other framework integrations. And it also works by using the declarative shadow DOM, which is a new browser feature that allows shadow roots to be attached during HTML parsing without use of any JavaScript. A little caveat on there, as for the browser support, it is currently shipping in Chrome and Edge. It is prototyped in Safari very recently, which is exciting to see. Not yet implemented in Firefox, but there does exist a very lightweight polyfill, which can be inlined. So that will require JavaScript to be enabled. But we're excited to see the declarative shadow DOM work in all major browsers soon. So let's take a look at how it actually works. So let's say here we have a Lit template here with a custom element inside of it. Now, if we pass this into the render function from the Labs SSR package, it produces this HTML markup with the declarative shadow DOM. This part here, the template element with the attribute shadow root, is actually the declarative shadow num part. This part is built by the render from SSR based on the component definition. So you'll notice this part is not in the markup on the left, but this comes from the render method of the component definition, which lit SSR picks up and then spits it out here within the template shadow root. So the next step would be to take this and we pass it on to the browser. So the browser, as it's parsing this particular HTML, it can then go ahead and generate this element tree rendered in the browser. You'll notice that even the H1 element in the light DOM is properly projected into the slot. All of this, again, without JavaScript for browsers that have this implemented. So the next step here, optionally, if your component has some interactive bits and needs to be hydrated, what we can do is go ahead and bring in the lit experimental hydrate support, as well as the component definition here, which is a simple greeter here. You can do this in any ways. Here I've chosen to add a script tag that brings this in along with the page. You can also do it in other ways where perhaps on a mouse enter, dynamically import these. So the lit experimental hydrate support patches our lit element so that when the component definitions are loaded, as the components upgrade, they will actually hydrate the component rather than trying to re-render them from scratch. So by doing this, any parts that have interactivity, like this button here, we can have an event listener registered, just like that. So we took a look at this sort of a high-level view of how it works. Let's dig into a little bit of code. So let's say we have a COA server here, and we're writing a handler for the slash route, and we're setting the response body as a readable stream. And let's assume we have some header and footer content for the page that we want to include that doesn't involve any custom elements yet. The middle part, the content, will require lit SSRs though. So first we'll go ahead and import render from lit SSR. And then we're going to spread the result of the call here in the middle. We're providing it some template with a data object here. Here I've hard-coded it with the name friend. You can imagine you can even pull this data from the request context or such. The get template function looks like this, where we're taking the data object and returning out a lit template here with the simple greeter, giving it the name attribute from the data provided. So this, as we've seen earlier, the render function will go ahead and turn that into a HTML markup with a declarative shadow DOM. And this will be embedded as part of the response body from the server, and the browser can go ahead and parse all of this for the initial render of the page. So let's take a look at what's new that we've been working on recently. So some things that we want to cover here, we'll talk about the SSR docs on our lit.dev site, as well as the 11D plugin package and the testing package. So for the docs, we have a new server rendering section in our lit.dev page. Please check it out. We have some good documentation on server usage, as well as client usage, including different hydration methods, as well as tips for authoring components that are SSR ready, including what life cycles are called on during server rendering and such. So please do check this out, and we will keep these updated as we make changes to the SSR package. We also have a brand new 11E plugin for Lit. It's very exciting. So the 11E plugin Lit package is a plugin for the static site generator 11T. And it actually lets you server render lit components during build time generation of static assets. So let's take a look at how this can work. First, you want to go ahead and install the package, and we'll configure it in our 11e config, where you can provide the component modules that should be loaded for server rendering. Once this is configured in 11t, let's say we're building a page with some markup file. Here I have an index page where I have a couple of custom element tags embedded here with the QR code SVG components. And since I've provided the component definitions here in the config, once we go ahead and run the npx 11t build command, it'll go ahead and generate this HTML with the custom elements all rendered out here in static HTML. And when this loaded in the browser, we have a page with all the things. All right. Another thing is the testing package in the labs. So this package includes testing utilities to easily check whether your components are SSR or server-side rendering compatible. And you can write tests against for elements rendered in the client as well as the server with the same assertions. So it uses a plugin for Web Test Runner for the server rendering portion of it. And let's take a look at what this looks like. So here, let's say we have a test that doesn't use our package yet. It does utilize the fixture and insert from the OpenWC testing package, which is excellent. So this right now, as it is, will only run in the browser, and you can only test client rendering of this particular element. By using the Labs testing package, we can go ahead and test it in multiple environments. So we're going to bring in the CSR fixture for client-side rendering, as well as the SSR fixture for server-side rendering. And we're going to go ahead and run this in a loop. So for this syntax right here, we're going to take both of these fixtures, alias it into the just a generic fixture for ease of reuse. And then for each of these fixture functions we're providing, we're going to run the entire test suite on those. So that way we can go ahead and reuse all of our assertions for both rendering methods. One slight difference for our fixture is that we do require that you provide a list of modules, since we need to know what modules to load during server rendering that contains the component definitions. So with this, if your component has something where it's not server renderable, for instance, you're trying to add an event listener somewhere in the lifecycle that runs in the server, this will easily catch it, and you can go ahead and fix it, and now your components are server-side compatible. Another cool thing we've added is a is-server environment checker. So this is now part of the lit package, as well as the HTML. You can directly import it from lit. And it is a const value, which will be true or false, depending on the environment that this is being imported in. And because this is a const, static analysis tools can be used to actually eliminate dead code from client bundles. So if you need to do some work in the server, but not in the client, using this, you will not have to add additional code shipping to the client. Quick demo of this. So for instance, we import the is server from lit, and then you can go ahead and use it in some condition check where, for instance, this code as it is will break on the server because add event listener is not defined for this element in the server, but this code can escape that. All right. Some other things we want to highlight are community integrations. Early adopters of our lit SSR package, both Astro and Rocket have added integrations for using lit SSR within these frameworks that you should definitely check out. And we're excited to see community efforts around using lit SSR. All right, so for a bit of a status update on the package, we say that put it in not close to GA yet, but we do need to work on some more bugs and features. Particularly the SSR approach is actively being worked on and may have potential breaking changes, such as how the API looks, as well as what life cycles are called on the server, which is why we're not saying that this is close to GA yet. Some known issues and outstanding features that we do want to work on is definitely handling asynchronous rendering during server renders. Currently, everything is synchronously rendered, so we can't render anything with promises or such. We do also want to support events and protocols such as context. And we also want to work on integrations with other frameworks such as Next and Nuxt and Angular Universal. Next is currently being worked on by the team. We also have great community effort ongoing for Nuxt integration. So we're excited to see those come to fruition. And we're looking for feedback on API ergonomics, as well as any missing features, or if you have incompatible components that you've seen, or any other use cases of SSR that you're not seeing covered, please let us know. You can file issues, write in discussions, join our Discord channel to discuss, and all of that. So with that, thank you very much.
Great job, Augustine. Thank you for a great presentation and also for all the work you've been doing lately on SSR. Very much appreciated. Okay, so next up, I'm going to invite Kevin Schaaf. Take it away, Kevin.
All right, thanks, Gray. Hey, everyone, I'm Kevin. I'm an engineer on the Lit team. And I'm going to give a quick overview of work we're doing on a Labs package to automatically generate framework-specific wrappers for Lit components. So the goal of this work is to make it easy to give a first-class experience to using Lit components in popular frameworks. Before I jump in, I want to first talk a little bit about Web Component superpower that lets them work in any framework, but then talk about some areas where using web components and frameworks still hits a few rough edges and how wrappers around Lit components can help sand off those edges. And then work that we're doing in Labs to automatically generate wrappers for your Lit components. So Lit components are web components, and this means that they come with a superpower that all web components have, which is interoperability. The superpower comes from the fact that they can be instantiated just like any other HTML element. You can use them in static HTML markup, of course, or you can use any of the built-in DOM APIs to create new instances of them, like inner HTML, or the imperative DOM APIs like document create element. And this is key because since any framework that creates DOM has to use one of these APIs, that means that any framework can automatically create web components. And this is why you can use web components like Lit in React templates, and in Angular templates, and in Vue templates, in just about any framework out there, and they just work. In fact, you can go to customelements.everywhere.com, which is a website, to see how well web components work out of the box in just about any framework. The site runs popular frameworks through a series of tests to make sure that the framework doesn't do anything weird to break compatibility with web components, and they all do really great, with one notable exception in React. React has historically kind of had trouble with some DOM concepts like setting event handlers on and properties on web components. And the good news is that they've already landed fixes that will address those issues in a future version of the framework, giving them 100% on custom elements everywhere as well. So the takeaway is that web components interoperability means that web components will work just about anywhere. And this solves an important problem that a lot of companies face. They have to support a lot of teams building applications using a lot of different frameworks. So Lit and web components allow teams to write design systems and other reusable components once, and then vend them to internal customers and external customers, building whatever stack they want. But while web components work in every framework, we found that there's a little extra work that we can do to make Lit components work even more seamlessly in the most popular frameworks. Make them work just like any other component in that framework. So the concept here with wrappers is that we still want to do all of the heavy lifting in our web component. So all of the state, reactivity, the template, the styling, the event handling, the accessibility, we're going to do all of the hard work in our Lit component, just like normal. And then we're going to wrap the component to provide framework-specific integration to make the Lit component feel really seamless in a given framework. And then that wrapper, that framework-specific wrapper, basically just delegates to the web component for everything else. So let's take a look at what types of things that our wrapper adds. Like I said, web components basically just work. So there's only a few things we have to do to make them really look seamless to a given framework user. So in our React wrapper, for example, what the wrapper does is it's really just providing template type checking. So it adds TSX compatible TypeScript types for properties and dispatch events so that when you're writing it in a TSX template, you can get the full power of type checking. And then, like I mentioned earlier, React has historically had a few issues with some DOM concepts. And so until React actually ships that, our wrapper can fix those up. So we can provide disambiguation for properties and attributes so that those are set correctly, and add JSX properties for event listeners so that you can pass event listeners in idiomatically. So really, that's all we have to do to make React work, or Lit components look like any other React component to a React developer. And then there's a couple of other ideas that we're thinking about adding to the React wrapper, things like idiomatic slotting, so that JSX render props could map to web component slots without having to write the slot attribute, or context integration, mapping React context to that community protocol that Lit implements that Justin covered earlier in his labs talk. So these are kind of just a little extra work we can do in a wrapper around Lit components to make them really seamless. And then same for other frameworks as well. So the things that we're doing in our Vue wrapper is, again, adding template type checking. So each framework tends to have its own template syntax and type check, framework specific type checking. And so Vue is no different there. So we want to make sure that Lit components can type check correctly when you're using them in Vue templates. And here we're already mapping Vue's vslot attribute to web component slot attributes, so that the way that you slot child nodes and components in Vue feels idiomatic as well. And then so we've got this much working so far, and then we're considering adding forms integration. So Vue has a vbind concept for binding to form components that we think we can make go. And then if we look at Angular, the things that we're looking at doing in the Angular wrapper, again, adding template type checking, and then scheduler integration. So Angular has a kind of bespoke way that it schedules work as components are rendering down the tree, and we found that we can integrate with their scheduler to ensure that using Lit components doesn't have any sort of performance impact there. And then again, similar, we may look at adding forms integration. So Angular has a forms system as well. And then similar to React, we think we can probably work out how to map Angular's dependency injection to the Lit community context protocol. Okay, so in general, the wrappers are fairly straightforward to set up. Particularly the React one it's a little factory, and we have a talk coming up where Brian will go into more depth on what it's like to set that up. But it does require mapping certain things from the web component, kind of the shape of the web component, describing those to the wrapper, and so that's some work that you have to do to keep those in sync. And so another area that we're working on in Labs is automatic wrapper generation. And this is the kind of user experience that we want all Lit developers to have in order to support the most popular frameworks. All you'll have to do is pull up a new Lit CLI, run the gen command, point to the path on your file system that contains Lit components, tell us what frameworks you want to create wrappers for, and the tool will generate those for you. So that supporting the different frameworks using Lit is as simple as running one command line. So this is the goal where we're headed with these Labs packages. We're going to build up to this with a series of, this is decomposed into a series of Labs packages, starting with a new Lit CLI. The wrapper generators are just kind of one one command that we expect to have in the CLI, but the CLI can be a kind of a host for any sort of build time things that we want to add in the future in the lab space. The next thing is that we've got a new package called Lit Labs Analyzer, which is a static analyzer for Lit source code, and can generate a model. And actually, so the model stored in memory is very similar to the community protocol around the custom elements manifest, and we'll eventually be able to generate the manifest as well. But we can then use this static analysis, this model of the Lit components that you've written in order to generate the different wrappers. And then we've got, we're working on a wrapper generator for React, Angular, and Vue. Again, with the goal of generating these framework wrappers as simple as one command. All right, so to take a look at where the status of this package is, for this one, we kind of put it still under development. It's not quite ready for usage, although it's getting close. The kind of known outstanding features that we're looking at doing. So Vue and React are already, we have basic support for Vue and React generation done. The Angular one is still a work in progress because there's a bit more sort of a boilerplate we need to integrate with there. And And then we've got a bit of code analysis features that we still need to do to cover most common use cases. And we've got PRs up for a lot of these now. So these are kind of coming in, but we know that we need to cover subclassing and mix-ins. Those aren't quite done in the analysis. And then we know, because users will have lots of varying ways that they lay out their packages, we want to make sure that the static analysis can handle analyzing various package layouts. So we'll go through a round of kind of testing against real world code that's out there. The wrapper generators actually generate npm packages for your components, so that you can publish like the view component separate from your web component, if that's a goal for you. And so because of that, we generate some boilerplate like package JSON. We know that we'll need to make those more configurable, so that kind of work is not yet done yet. And then for any of that boilerplate that we do spit out, we expect that we'll need to have features that allow updating previously generated wrapper packages that might have hand edits in them. So that's all kind of work that's still upcoming. And then finally, Augustine gave a talk on the work we're doing in Labs SSR, and the fact that we're working on framework integrations for SSR, and we need to make sure that the client-side wrappers and the server-side wrappers all play well together. So that's all work that we've got mapped out coming up. And then the things we're looking for feedback on, again, it would be useful to know how common needing to modify the generated wrappers will be. So if you can anticipate things that, if we generate wrappers, things that you might need to augment or edit, that would be useful to know. And then, another thing kind of further down the line is thinking about how the generator wrappers get tested. Generating tests for the generated wrappers is currently out of scope, but we'd like to hear your feedback on that. And in general, general thoughts and features around this type of code generation as well. So you can check out the discussion page for this. Eventually, the packages will be available. They'll be consumed through the litlabs/CLI. So that is the package that we'll point you to once this is all ready. So that's where we're at. Thank you very much.
Thank you, Kevin. It is exciting to see this integration work happening. Sometimes even superpowers need a helping hand, and that's what we're looking to do here. So thank you. Next up, on a very similar topic, we have Brian, and I'm going to bring him up to talk in depth about our wrappers for React. Take it away, Brian.
Awesome. Thanks, Greg. Good to be here. Good morning, everyone. Hi, my name is Brian Taylor Vann. I'm a software engineer at Google on the Lit team, and I help maintain the Lit Labs React package. And today we're going to go into a little more detail about the Lit Labs React package, because it's definitely a little more special than the rest of the wrappers. So this will be a continuation of what Kev was discussing, and let's get started. We're going to talk about some developer stories. We're going to talk about why we built this package. We're going to talk about the package itself and how it works. We're going to show an example, and then we're going to talk about a few things we're trying to work on in the future. So when this package was created, we had two developers in mind. One was going to be the web component developer. They make a bunch of beautiful web components. They want to extend the reach of those web components as far as possible, different frameworks. They don't want to be limited by frameworks or other JavaScript libraries. The second developer would be the React developer. They're used to developing in a React environment. They deal with components when they build applications, and this React developer in particular might have found a web component that covers all the use cases, and they don't want to recreate that web component in React. They just want to use it because they're rendering to the DOM. But they also want to be able to develop and maintain their applications in a familiar and comfortable environment so they can keep up their velocity. And that means treating web components as a first-class experience. And what that means is we want to be able to give both the web component developer and the React developer the ability to share their web components and use them in React. Currently, what that means is React has some difficulties discerning differences between attributes and properties. Our web component wrapper will interrogate a web component for properties and then set them as properties, not attributes, when React updates properties. Events are also a little bit difficult. Currently, React does not handle attaching event listeners to web components in the same way that it handles vanilla DOM elements. The same thing goes for custom elements. And when you have when you have trouble with properties, attributes, events, you're probably going to have trouble with types too. In the experimental version of React right now, events are attached to the web component, but they still have problems with arbitrary events and typing as well. Some of the main differences between web components and React components are ergonomic. So for the most part, you can pretty much discern the differences between camel case and kebab case. In web components, your tag name might be my-component, while in JSX, it's a camel case my component. Same thing with events. And also in this package, you're able to choose a package that's not just React. You can also use Preact or other type of JSX module renderers. So let's talk about the LitLabs React package itself, though. Like I said previously, the wrapper interrogates a web component to find out what properties are attached to the web component. And then when React props are set on that web component, they are set on the element as properties, not attributes. And this solves a lot of challenges when it comes to using web components in React. The second big feature that we do is we actually provide the ability to map React property event names to custom element event listeners. So in this example, we have an onFoo listener that will be called every time the foo event is dispatched from a web component. And then, of course, we like to make sure that our properties, attributes, and events are well typed. And this is an example of how the syntax looks when using this wrapper. So Kevin mentioned how the wrapper sort of automatically generates properties, but that's based on interrogating and analyzing the web component itself. This is a more manual way of doing this, where you can provide a React module, you can provide the element class, you can provide a tag name, and an event map. And this create component function will then generate a wrapped web component that works just fine in React. So let's take a look at this in action. So here we have a web component called super button, right? It extends lit element. It's got a property called name. And every time a user clicks on the web component button, the onClick method is executed, a custom event is dispatched, and it has data that is derived from the property on the web component called this.name. If we go over to our React app, we can see that we're just using a vanilla web component out of the box. Super button, we've provided a name called Taylor. We've provided an event listener for onMessage. But when we go over and use our web component, nothing happens. This is kind of expected, and this is where the create component function really shines in our LitLabs React package. So let's go ahead and import that, and we'll also import a typing to help us with our events. We're going to import the web component class itself, and then we're going to call create component. Here's where we're going to provide a few arguments to create component, including the React module, a tag name, the web component class itself, and then we're also going to provide the mapping for our onMessage event listener. This is going to tie everything back into the React app, and we're going to use our camel case instead of kebab case. And now we have access to both the event listeners and state inside the web component. And this is kind of the relationship that we want to provide for web components in React, the ability to drill properties down and the ability to listen to events that come from the web component. And that way we have access to state on the web component in React, and you get a chance to reconcile component state with React state. Sweet. There's a couple more examples. This one was pretty basic, and this is the base case that we want to provide as like usability for this package. If you go to lit.dev/playground, you'll see other examples that show you how to use React events, custom events, how to use slots with web components in React, and how to use refs, which is really important when you're trying to reconcile web component state and with React state. In the future, we have a couple of plans for the React package. Kevin did mention that we have a few features coming out. Mainly, I know people are going to wonder, is this compatible with Next.js? And the short answer is we're working on it. Next.js and other SSR frameworks are a forefront in modern web development, and currently we're researching best practices. Another web component developer story might be, hey, I developed dozens of web components, and doing this manually each time feels kind of cumbersome and a little heavy. And we understand that. And that's exactly why Kevin and the team are working on the CLI tool to automatically generate wrapped web components for any framework, including React. And that's the end of this talk. It was pretty quick. We went over one of the details of the wrapper packages called Labs React. We discussed the intentions of the package. We discussed who we're developing it for, and we discussed how to use it. Hopefully this helps unlock the power of web components in your React app. And thank you very much for your time today.
Thank you, Brian, for both your talk and for all your work on the React package. Very much appreciated. And so we now enter the portion of our talk, which if you've been following our YouTube channel, you know we have a couple of YouTube celebrities. And so the next two talks, no pressure, guys. Anyway, I'm going to welcome Andrew Jackubowicz up onto stage and let him tell you about Lit Labs observers.
Hi, thank you, Gray. Hi, I'm Andrew Jackubowicz, and I work on the Web Components team at Google. Welcome to this lightning talk on the Labs Observers package. I'll cover what the Observers package is, then show 2 motivational demos for using the Observers package. Finally, I'll wrap up with the status of the package. The demos can be viewed through these links, so you can pull them apart and dive into them more deeply in your own time. So what is the Labs Observers package? It's a tiny package that provides reactive controllers for 4 browser observers: the resize observer, the intersection observer, the mutation observer, and the performance observer. Each of these observers accepts some kind of callback function and will call the callback when some kind of change is observed. The resize observer can be used to report changes when a DOM element's content or border box size changes. The intersection observer reports when an element comes in and out of view. The mutation observer watches for changes made to the DOM tree. And finally, the performance observer reports changes in various metrics about browser and application performance. These browser primitives give you a lot of power. The Labs Observers package exists to make using these primitives more declarative and easier in Lit. And this is done by exporting each of these observers as reactive controllers, respectively called a resize controller, intersection controller, mutation controller, and performance controller. Additionally, the Labs Observers package removes boilerplate, the controllers hook into the Lit element reactive lifecycle, the controllers are easy and declarative to use, and we maintain it for you. These controllers are also tiny, so you can read and understand their 100-ish lines of source code. So let me show you some of these benefits more concretely. This is the lit.dev playground, and here we have an index.html page with 2 elements: a mock drawer, which can open and close, and a simple resize demo element. The simple resize demo element should communicate its width and height in pixels in the center, currently displaying 481 by 100 pixels. Note that when I open and close the drawer, the width and height text in the center of the element doesn't update, even though the render method is querying the element's client width and height here. We need some way to detect this resize change to then schedule a reactive update on our element. We can't reach for the resize event on the window to detect the change because it doesn't handle some other element on the page causing our element to resize. This is the perfect situation for the resize controller, which, as you now know, observes the element and requests a reactive update whenever the element is resized. We can import the resize controller from the Labs package, then initialize it on the demo element. Now, the resize controller schedules reactive updates when a resize change is observed, which results in the text updating with the new dimensions. And the resize controller handles both the window being resized or the element being resized due to layout changes around it. Nice. Thanks, resize controller. This second demo shows off the intersection controller. So shown here is our elements render method. We're iterating over a static list of shapes and generating a div for each one. The most important thing to take note of is that each shape element has this monochrome class, and currently it is always set. The result of this markup is a scrollable list of squares. If I remove the monochrome class from the divs by setting it to false, you can see that these divs become very googly shapes. So this is what I desire, for the colorful shapes to only appear when between the dotted blue lines. Otherwise, the shape should remain black squares. So functionally, I want to toggle the monochrome class based on whether the shape element is intersecting the viewport. With the intersection controller, we can observe child elements, and then we're told when the elements come in and out of view. So let's instantiate the intersection controller. The margin of the viewport can be set with a property called root margin, represented here by the dotted blue lines. This config says, tell me when the elements come in and out of this area. Whenever an observed element comes in or out of this view, the intersection controller callback triggers. And we do some bookkeeping to store which elements are currently visible in this isIntersecting set. The intersecting set returned from the callback holds all the visible element IDs and is assigned to the controller's value property. And we're going to use this to toggle the monochrome class shortly. We also need to tell the controller to observe these child elements. So finally, we can use the controller's intersecting set to answer the is the element in view question, selectively toggling the monochrome class in the template. And now when we scroll, the shapes appear only when in view between those dotted blue lines. So in a real situation, you may use the intersection observer to trigger something expensive when the element comes in and out of view. Hopefully I've got your appetite to explore the intersection observer further. There's also the mutation and performance controller, which I did not have time to cover in a demo. They're interesting and you should check them out. So what's the status of the Labs Observer package? Well, we think it's a useful concept, but there is some room for improvement, specifically around providing a declarative API for observing children. So as you saw in the second demo, with a declarative directive-based API, that boilerplate for observing child elements will go away, as well as the callback code, that bookkeeping, and the new API will also be more flexible for observing dynamically rendered children. So we won't have to imperatively select them. We think use cases like that second demo are awesome, and we want to support them. DOM observers already give a ton of power, and this package exists to make using them more declarative and easier in lit. So where this isn't happening, we'd love to hear your feedback. Try out the observers package today. It's been a pleasure. Thank you.
And it's been a pleasure to watch, Andrew. Thank you. All right, so up next, from the host of Build It with Lit to the host of Lit University, let me welcome Elliott Marquez.
Yeah, thanks, Gray. Hey, everybody. So I want to talk about something from my experience. So having worked on Lit for a while, there's a question that I keep hearing that I don't think we've really fully answered. Where do I put my async work in Lit? Like fetching data from a server, for example. So, hey, everybody, I'm Elliott. I'm here to propose an answer to that question. Let's talk about task. But first, what does task do? In short, Lit Labs task makes your async code faster to write and more focused. Let's go into an example where you might need it. Probably the most common one that you might be familiar with is fetch. It fetches from the web. It's easy, but handling the edge cases can be just like a little bit hard. So let's build an app that handles fetches comprehensively. An app that does the following. It does the fetch. It updates the property. It updates reactive properties with the result. It redoes the fetch when specific properties change. Keeps track of the current request state. Handles errors. Handles race conditions. And renders different things based off the current state of that fetch. So I know it's a lot of requirements, but this handles almost everything you would basically need around a fetch. So we're going to create something called Taskit. So given a subreddit that is a topic on the site Reddit, this component will fetch the Reddit API, render the first page of photos in nice cards, and it can also show a loading spinner when loading the data and handle error cases gracefully. So let's see how this is done without task. Just a heads up, this is going to go a bit fast, and I'm going to implement it in the order that you logically would. But really, I want you to pay attention to the code flow and how you move around. So think of the right-hand side as your mental position, and the left-hand side as your physical position, like where you're actually typing in the code. All right, let's go. First, you create the method that fetches, call the fetch every time the subreddit changes, Save the subreddit as a reactive property, save with the fetch result and the fetch status. Now we actually do the fetch. Now you need to handle race conditions with the dirty bit checking, parse the output. Oops, this might throw an error, so put rapid and try catch. On success, format your data and set the status to complete. On error, clear the data and set the status to error. Okay, so now the data's hooked up to the fetch, right? We're done, right? Nope. Now we actually got to render it. First, create a switch based on the status, render your error case, render the cards with the data on the complete case, render the loading spinner on the initial and the pending cases. Are we done? Yeah, okay, yeah, we're done. So this is the overview of doing comprehensive async task handling today without any helpers. You store the state and the result as reactive properties. You perform the async task every time subreddit changes, make a dirty bit to debounce load task, aka handle race conditions, keep track of current request state, do your task, handle errors, render based off the state. Okay, so back to the initial question. Where the heck do I put my async work in lit? Well, today we're suggesting maybe not this. Like, it's doable in lit without helpers, but it's a lot to keep track of. It's a lot to get right, and it's just a lot all at once. You're having to do a bunch of mental shifts from concept to concept while also jumping all around the code. So one option we're proposing, not necessarily the option, is how about lit labs task? So remember the comprehensive requirements we had for our app that we were building? Well, surprise, it's actually what lit labs task does. So task does the following. It does async work. It updates a reactive controller with the result. It redoes the async work whenever specific properties change. Keeps track of the current request state. It handles errors. It handles race conditions. And it renders different things based off the current state of your async work. So let's migrate the starter example to task just for an example. So here's the before and after code. Let's walk through it. First, handling race conditions in your task. So when you invoke several async tasks after each other, they may not necessarily resolve in the same order, so you need to keep track of what is the latest task. Task just does this for you. It makes sure you only render the last invoked task. Task keeps track of the current current status, initial, pending, complete, and error. Task also handles error checking for you. So what are you left with? Well, the code you actually care about, the task itself without any of the bookkeeping. Next, we place this task into the task controller. Let's walk through it. You instantiate it. It's a reactive controller, so you pass it the reactive controller host, the async task itself, and a function that returns a list of reactive properties that will trigger the task whenever any one of them changes. Let's talk about that just for a bit. So this reactive property array is equivalent to checking if the given properties have changed since the last update. So we don't have to keep track of that anymore. Next, the render. It's largely the same here, but just a tiny bit simpler. The task instance has a render method on it. You pass it a function to render the initial and the pending states, error cases, and when it's complete, it will pass the result of your task to a function that you provide. In this case, we just render all the cards. So how does it look? Well, it looks largely the same. You have subreddits changing, cards with images and links rendering, and a progress circle in between. So now you may be asking, what's the difference? Why should I care? So line difference wise, you go down from about 60 lines down to 39, and your code is much more focused on the tasks that you have at hand, no bookkeeping. And remember the steps that we had to take to build our app? Task takes you down to this. You do the task, then you just render your states. There's a lot fewer steps to accidentally forget or mess up. Again, lit labs task makes your async code faster to write, more focused, and task is more than just fetch. You can do almost any async work you want to do. So for example, you can request media permissions. Again, let's step through this. You instantiate, you pass it the task. In this case, we ask the navigator for the webcam. And then here we have turned off the auto run feature. This is what I call manual mode, where the task will run on property change. This is useful really only when you want to run a task once, or simply want to have a bit more control for when it runs. For example, like you don't want to ask for video permissions before the user has even interacted with the page, because then it just won't ask for them. So now let's take a look at the render. On the initial state, we just show a button and manually run the task with the task's run method. Then on complete, simply pass the camera stream to the video tag source object. And then if they reject the permissions, just display an error. So how does this one look? So we have the initial button rendering right there. And then if you click, you run the task, on pending, show the spinner. And in this case, we'll reject the permissions, which will throw an error and render the error state. All right, let's reset permissions and try again. So you click the button, run the task, show the spinner, and let's accept. Success! We have a live stream. Welcome, everybody. So let's go over the concepts of task one more time. You write it, you render it, and in the case of manual mode, you run it. So the status of task is that it's close to GA. The feedback, what we're looking for is that it needs community feedback. It's a simple implementation, so it's usable in prod. We don't really expect any bugs, and the API may have some breaking changes in the future. The feedback that we're looking for in particular is, does it need more features? Does this fit your real-world use case? And do you even need this? So install it and give it a try. I'm Elliott.
Awesome. Elliott, I'm looking forward to watching the live stream of you holding dog pics on your phone. So be sure to get that ready and put it up on YouTube for us. All right. Thank you, Elliott. I am next going to welcome Brendan up to stage, and he's going to tell you all about Lit Labs Virtualizer.
Hey, guys. I'm Brendan Baldwin. I'm a software engineer with the Lit and Web Components team. And for the last several months, I've been focusing my attention on the Virtualizer project, which is the latest and most elegant iteration in a long lineage of DOM virtualization projects. I want to just go briefly over what problem we're trying to solve, give you an example, and then show you our solution, and then dive deep into a little of the extra features. And then what are some of the special things, the considerations, and move forward. So here we are. So what's the problem? Virtualizer means to actually solve a few different problem areas, but I'm going to oversimplify for this talk and focus on one and just talk about the DOM, or rather too much DOM. What do I mean by that? I mean, the DOM is great. It enables us to define and interact with all the bits of our page and the entire foundation of the interface of the web and all that. But every single element and bit of text and comments and white space is all represented in a big, big data structure we refer to as the DOM. And some nodes of that are cheap, white space, text, comments, divs, and then some get heavier because there's more information like audio and image data and iframes and that kind of thing. The bigger your DOM gets, the more expensive it is, obviously, to find things. Query selectors take longer. You have to iterate over more stuff. But the real impact of having lots and lots of nodes in your DOM is anytime something in your DOM changes, the browser has to recalculate layout and style, what's typically referred to as a reflow. And so when your document represents large collections of things like messages or products in a catalog, news articles, search results, whatever, you're going to have a proportionally large amount of nodes in your DOM. And you get those higher layout and reflow costs, and that starts to interact and compete with other performance costs and application memory consumption and transitive effects. And then there comes the point for any app where if you get too many nodes in your DOM, you're going to have noticeable effects and they're hard to diagnose. And then maybe you're not even testing your users' real world collection sizes. And anyway, stuff doesn't work and feel right. And we tend to design around this intuitively, right? We try to not overload our interface. So we come up with different metaphors. What can you do? You can paginate, right? But it's 2022. There's a better option, right? So before I get into how that works, just let's briefly talk about what is too much. How many nodes are too many nodes? Lighthouse, which is kind of the sort of standard way of measuring your web app's performance. It has guidelines that say, hey, if you got 800 nodes in your DOM, that's too much. 1,400 nodes, I'm going to scream at you. But the most important piece of advice that it gives, the most important guideline, is it says, if you have any parent node that has 60 or more child nodes, it's basically saying your list is too big. Find another way. So let's look at an example. Here's a large collection rendering problem. Simple example here is a list of photos, right? We've got a 1,000 some odd photos. We want to render them to the page. Obviously, there's going to be some expense there. So we give an array of photos to our custom element here. You can see this is our basic photo list custom element. It's very simple. It has a photos array, and we're going to go ahead and emit each one of them as an image tag. This is the simplest possible example I could do. So that's 1,000 image tags on the page. In a real app, you'd probably have more than just image tags. You'd probably have, divs around it for like a label, and maybe you've got a little, kebab menu for doing things with the image when you download it or whatever. So you're going to have a lot more stuff in your DOM than just the 1,000 image tags. You're going to have maybe 10,000 tags or something. So that's a lot of data and requests also to the images across the network that you're going to be doing. Here's just an example. I've gone ahead and rendered it, and you can see in DevTools, I'm just going to scroll through there the actual rendered image tags. And okay, so this is what we're trying to avoid, right? So how do we avoid this? Solution. Here's your solution. Go ahead and install Virtualizer. And this is just an example of what it looks like. It's a custom element, lit Virtualizer. You define the items that you're going to render, and then you define a little template to render each item. It's a really simple interface. You can probably get up and started in about a minute. The premise is you don't have to render everything. You don't have to render every photo. We're only showing some on the screen at any given time. What if we just rendered the ones that are actually visible and make sure that the scroll bars and everything else act as if we did render everything so that it feels natural. Here's just sort of a very advanced rendering that I did earlier today to show you what lit Virtualizer is. Here you can see lit Virtualizer. It's an element. It's a container. All these are the items that we're rendering. But what lit Virtualizer actually does is it goes ahead and it only renders the things that are going to be in view in the viewport. It still keeps its size as a container as if it was rendering all the things, but it's only going to show you the things that you could see. So as you scroll around, it's going to change out those items so that you can feel like you're looking at a giant collection. So I'm just going to show you briefly how to convert your application if you already have large collections. It's a multi-step process. The first thing you got to do, find out what you're doing to render. You're probably using a repeat, right? Here's your repeat. You're going to swap that out, and you're going to put a virtualizer instead of a repeat. And then step 3 is, no, actually, that's it. That's all you really have to do. Assuming you don't have a bunch of edge case stuff, this is going to handle most of the circumstances where you're rendering a collection of things. So here's just a live example that I recorded and is no longer live, where you can actually see I'm scrolling through the items, and in DevTools, it represents in purple those DOM nodes that it's actually adding and removing. So as we're scrolling, you can see it's actually inserting and deleting DOM nodes. So that's pretty cool because that means now we have a fixed, we have a fixed number of elements being rendered at any given time. Instead of the 1,000, we actually have 12, right? So that's cool. That reduces the number of things we have in the DOM at any given time. Our reflows are going to be cheaper. We're only making 24 requests for images on that first load. And the other cool thing about that is you don't have to implement anything special for lazy loading image behavior, right? So it's like you get this extra free benefit. So how does this actually work? Well, what Virtualizer does is it'll essentially, by default, it's going to estimate how big it would be if all of its children were rendered. And it does that by looking at the children that actually will render in the first set. And as it goes ahead and makes that estimate, it'll adjust its awareness of how big it should be and make changes to its estimate as you scroll through, so it can get a good understanding of your document set, and your scroll bars will feel real as you're moving around. It's also very responsive. If you zoom or increase your text size or resize your browser or frame size, or if any of the child nodes themselves change their size because of some other thing that has nothing to do with Virtualizer, it's going to go ahead and react and adjust all of its concepts of what should be in view in real time. So it'll feel just like a regular rendered collection. it's the child nodes that it's rendering remain in the light DOM, so you don't have to do anything special to style them, and it'll automatically add and remove them based on whether they're actually deemed to be in range of view, and it already understands what items are to the elements that are rendered, so you don't have to think about creating keys for them like you might with repeat. It's just kind of a freebie. So getting into the features for this product, there are some other things that you can do. Like, what if you have a horizontal collection, right? By default, your block level elements are going to render vertically. Virtualizer has to understand that you're going to scroll horizontally so it can understand things. So you're going to give it what's called a layout. By default, it uses a layout called flow. That's where you can kind of give it anything, and it'll just do the standard vertical arrangement. But you can tell flow to say, hey, I want to use a horizontal orientation. So you can go ahead and import the flow layout and give it a direction. And I'm saying I'm going to render this horizontally, and then it'll just work there too. In addition to changes, configurations for flow layout, we have support other layouts. There's a notion of a grid layout. The idea being, instead of having to estimate and figure out how big your child nodes are going to be and adjusting over time, you could just establish up front a fixed item height and width, and then you can avoid all those additional calculations and churn. We're also going to be launching a masonry layout soon, which gives you a little more flexibility if you have various aspect ratios, but you want to have them more arranged instead of one at a time on top of each other. And we want to be able to support user-defined layouts too, but we really want to get the API stable enough so that we're not making you constantly have to rethink how you code them. So that's coming. We're looking hard at that. And so, in addition to other layouts, there's other behaviors that people are familiar with when they're using virtual scrolling kinds of libraries. Like, what about the infinite scrolling solution? Or what if you want to have on-demand data loading for certain items? Virtualizer is really focused on being a simple, primitive thing that's only concerned about pretending to be a fully rendered collection and only rendering things in view. That's what it's focused on. And if you want to be able to do things like infinite scrolling or do on-demand data loading for things that come in range, we make that very easy. And to build a component on top of that does infinite scrolling is just a matter of hooking into our event system. So Virtualizer will emit two different kinds of events. There's a visibility changed event, which is we send an event when new nodes show up in the viewport or disappear from the viewport, anytime that range changes. Then there's a range changed event, which similarly, Virtualizer, in addition to rendering things directly in the viewport, it has a little bit of an overhang, we call it, where before and after the visible area, it's going to pre-render some content so that the scrolling feels naturally. You're not constantly scrolling into blank space. And these events just give you the first and last item index that are now in those various ranges that you care about. And then once you know those, it's very easy to add logic to do things like go ahead and request the new items for the infinite scroll, or request additional data for your items to display. And another feature that we have is this notion of a scroller. The premise is here, by default, how Virtualizer is going to basically be that big element that pretends to be containing a whole collection. Well, sometimes you just want a little viewport that you can scroll around in. If you give the scroller attribute, then basically what you get is, instead of a giant collection item that it lives inside another viewport, Lit Virtualizer will itself be a little viewport, and you can style its width and height, and then just scroll around to see the items in it. And that can be really convenient if you're building a little list of things to browse. We also provide a directive, which is identical to the Lit Virtualizer custom element. You might want to use this if you were, let's say, doing something inside something that semantically didn't work to have a Lit Virtualizer element in it, like ULs and li tags. Or it's otherwise a situation where you don't want to bring in the Lit element base class, and you just want to use the virtualization capability. You can keep your imports smaller that way. Okay, so just a couple other things to keep in mind. you're virtualizing now. Not everything in the world is exactly the same when you virtualize. Obviously, you're going to be missing some DOM nodes that might have been there previously. So when you're testing, you have to be aware of how big your viewport is. If you've got headless browsers firing up for your integration tests and things, make sure you know how big they are, because Virtualizer cares. And so your test results are going to be different if you're expecting certain things to be in view. And they can't just assume that everything's going to be rendered to the DOM. So if you're looking for application state to be reflected in DOM, just be aware you're really going to have to focus your tests on what's actually going to be visible. Also, because there are little micro adjustments that happen very quickly in Virtualizer as it's figuring out where things are going or how much to render, you need to wait until it's done figuring those things out before you test that things are viewable. They happen before paint, but they're going to not necessarily happen in your testing cycle. So we have a little promise you can await. It's called layout complete. And when that resolves, that just means everything's done. So it makes testing very simple to make sure that everything's in place before you assert. Okay. That was it. Yeah. So to recap. Oh, I'm sorry. I couldn't see my slide. There's one other thing to note. Because things in your application are not always going to be all on the page, if you are trying to support users who would expect to be able to find using their native browser find feature, you're probably going to have to give them some affordance to do the same. We have a very simple API to scroll an item into view. So if you know the index of an item because your little application find feature has identified it, it's very easy to tell Virtualizer, hey, go ahead and scroll that thing into view. And now you've got all the features that you would expect your page to have. So to recap, Virtualizer is actually very usable right now and very useful right now as a tool to virtualize element rendering. It is intended to be a low-level primitive, so you could build elements on top of this and behaviors on top of this to do your basic, news feed and infinite scrolling and whatever comes to mind. We think it's usable. We're still working to get everything kind of covered test-wise. This is one of those components that has a lot of performance impacts. So we're trying to do a lot to stress test it and get really good performance measurements and understand what those edge cases are. Bugs still come in, but it is very usable right now, and we'd love to get more feedback on your use cases so we can make better decisions as we stabilize the API. And that's pretty much it. So thanks for your time.
Awesome. Thank you, Brendan. So we have just one more talk left. And before I bring Steve up, I just want to remind you that if you have any questions about any of these things, please go ahead and put them in the chat. I know we've been answering a bunch of them on the fly, but we will also bring some up at the end. We'll come back on stage and answer a few of them live. So with that, let me bring Steve Orvell up for our last talk of the show.
Cool. Thanks, Gray. Well, those are some tough acts to follow, especially Andrew and Elliott, our YouTube pros, and Brendan with a great talk on Virtualizer. It's pretty awesome stuff to see. So my name is Steve Orvell, and I'm an engineer on the Lit team. And today we're going to talk about the Lit Labs Motion package. And hopefully that'll be a fun thing to check out. So what are we going to cover? So first we'll kind of go over what the package is, some tips for how to use it effectively, and we'll illustrate those by looking at some examples. And finally, we'll look at the status and roadmap. So let's get started. So what is the motion package? Well, it's a set of lit directives for making things move. And right now we have just one, the animate directive, and it's actually a directive controller. And we'll see why in a little bit. But here's the code that kind of sets that up. This is the update method of the directive, and you can kind of see there that it calls add controller there on the element. Don't worry about the details. We handle that for you. But if you do want to learn more about custom directives and reactive controllers, definitely check out the docs on lit.dev. There's tons of great information there. So let's go ahead and just take a quick look before we go any further at some examples of what you can do with the API. So let's go ahead and check out. This is lit.dev. I'm going to go up here to the playground, and you can see a whole list of examples here. And down at the bottom, we have a bunch on motion here. So first, I'm going to just take a look at this sliding, super basic example, and we click this button, It sort of changes a class here with a click handler, and you can see the call to the directive when we don't need any setup at all. The styling is handled with CSS, and we'll dive into the details in a second, but you can see it's just that easy to use. Here's an example a little bit fancier with the lit sort of logo or just text animation. And here's a really good use case where we're just sort of taking a list here, make it a little bit wider, and just animating as we change the ordering of the list. And there's a little bit of a delay, and there's a little bit of setup here. Again, don't worry too much about the details. And if the fidelity of the animation isn't looking that great, again, you can check this out on the playground. If you want to dive into the code more there, you can check it out and fork it and modify it as you see fit. We'll go over a couple of these a little bit later in more detail. Here's a carousel example. And again, the rendering is just done with CSS, but the animation is done again right here with just a simple call to animate, nothing. There's some default options for sort of to make it do some basic duration and stuff like that. And again, the layout is handled with CSS, and animate directive does the rest for you. And I was hoping this would load faster, but this is using some MWC stuff. So yeah, it took a second. Here's a sort of canonical like to-do list type of example with two lists side by side. And we're using a little bit of a fancy behavior that I'll show in a little more detail later. And I went ahead and I did go running this morning. I'm not going to order clothes today, but I did go running this morning, so I'll take credit for that. And I'm going to give this talk. I'll add that and click it over there. Okay, cool. I'm going to give myself credit for it, even though we're not quite done yet. Okay, so those are just some quick examples of where we're going to go. And let's talk about sort of how it works now. So under the covers, we use what's called the flip technique. And this was a term coined by Paul Lewis a few years back, and it stands for first, last, invert, and play. And first, you measure and record the size of where the rendering of the element is. Then you kind of render it where you want it to go with CSS any way you want. And this is sort of the magic thing, and you record that position. Then you invert the position back to the first rendering position with CSS transform. And then you play an animation that just sort of undoes that. And what's magical about this is that it doesn't matter how we render the element, and we use these fast transform properties to perform the animation. So it's pretty awesome. If you do want to know more about the details, there's a recent YouTube video on this by Jake Archibald and Cassie Evans that goes into a lot of good detail about it. This is an awesome video, and they're great. So I definitely recommend checking that out. Under the covers, we use the Web Animations API, which I just want to do a quick shout out. This is the docs on MDN. There's a lot of great detail there if you want to check it out. This is an awesome API that's now widely supported. And what's great about it is that you can configure animations with JavaScript, but then you sort of let them go, let the browser run them. And as long as you're animating properties like transform that don't cause browser layout, it's done off the main thread, and it's super fast, and it's really great. Cool. All right, so let's kind of just get a little bit of sense of how that comes together with the animate directive. So we have the sort of reactive controller lifecycle. First, there's host update. Then there's the actual element updating where the rendering occurs. And then there's host updated, which is after rendering. So how does the animate directive perform the flip? So first, in host update, we measure the current rendering. We let the rendering just do whatever it wants to in update. And then in host updated, we measure the last position, compute the keyframes, and use element.animate, that Web Animations API, to play the animation. And that's just kind of how it goes. Okay, also in the package, I want to do a call out to, there's a thing called the animate controller, which is basically just a helper to coordinate multiple calls, animate directives together, setting some default options. It gives you a on complete for all the animations, callback in case you want to do something, and some controls for playing and pausing. We may do more there, but I just wanted to call that out. It's a useful other tool in the package. All right, so that's sort of a quick overview of what it is. Let's look at some quick tips for using it effectively. So first, like, what are some really, use cases when you really want to use the animate directive? So layout changes involving size and position, as we sort of saw on those examples. Adding and removing elements, doing this with lists, where lit is really good at doing that kind of rendering in a really declarative, simple way. And highlighting relationships with the elements, and I'll show an example of that in a second. Okay, when is it maybe not the right tool to use? This is sort of just important to understand. So, CSS is great for animation, and transition is useful in a lot of cases. And, again, the flip technique is awesome because it can animate basically any way that you do that rendering, whereas CSS transition can only handle CSS animatable properties. And you can look those up on MDN, but it's a subset of the kinds of rendering that you might need to do. Also, if you want to, because we use transforms to perform the flip technique, if you want to animate via transform yourself, you should do that on a node that's not got the animate directive, because that could otherwise conflict. It's a little gotcha to be aware of. And then finally, if you're doing something really fancy that, there's a lot of great animation libraries out there. And what we have so far does not have something like a timeline or a lot of coordination primitives. So we may get there, but for now, it's great to use those if you need a more complicated use case. So some tips for using the animate directive. Again, you can animate however you want, flexbox, absolute positioning, CSS grid, whatever you want. It's awesome. You can use multiple calls to animate together to produce some really cool effects like we just saw on the examples. I'll show an example of how you can use animate to avoid a little bit of a gotcha with text distortion. And you can actually add to the flip technique. You can add any other animatable CSS properties, and we'll sort of just pull those in and let CSS perform its magic there. We do have a guard function, just like task has, which will allow you to say when the animation should occur and make sure it does not doing those measurements on every single update, but only when certain data changes that you want to use to do the animation. And finally, you can do stuff. There's some callbacks. In particular, you can customize the frames to do some fancy effects. All right, so let's dive into some examples really quickly. So first, we're going to look at a grid layout example. And let me see here if I can actually move my mouse to the right spot. There we go. Okay, so let's go ahead and switch over here to our grid example. And this is just a rendering. You can see over here on the, this is a modification of the sample that we have on lit.dev, just to make it a little bit simpler. Again, it's very similar. We're just going to apply a class using class map when you click, and it's going to just call animate here. Again, no setup needed. And we're going to change the animation, and when we click here, it does the change here. Well, how is that working? Well, we're applying these classes, and I hid the styles here, but we're using this really cool ASCII art version of CSS grid to make this go. I love that syntax. It's just the easiest to use, even though it's maybe not the most practical for really advanced use cases. And just to show this working, I'll go ahead and change the ASCII. So I made that D column here wider. And if I want to sort of show what these regions are, I'll then label them, and then you can see. Okay, and then this is highlighting what I showed earlier, or what I talked about earlier, which is the sort of text distortion that we get out of the box. We're working on maybe handling that automatically better, but for now you can do, and I just sort of have some DOM down here, which is the same thing, but slightly modified, where I just did a little bit of extra nesting to put extra calls here. And what's cool about that is when we do that, it has a much nicer effect. So I just wanted to sort of call that out really quickly as a mechanism you can use. So again, we sort of just showed that in this example, you can animate layout changes however you want. It's easy and it's efficient. Nesting animations can help with that gotcha around text transitions. And I actually didn't highlight this, but we did actually customize the frames here. And I didn't really show, and I'm not going to show that code right now, but it did create really simple way to create that little bouncy effect, as you can see there. Okay, so let's move on. One more example here that we're going to look at, and this example is actually on the lit.dev, and that is this hero transition example, and it's just right here. So you can check it out in more detail because we're just going to go over a couple things. And there is a little bit to this one. But if I click here, you can see there's a list of cards. And then when you click on it, we want to show a detail for this card. So it does this sort of zoom out or zoom in animation on the card. And then when you click it again, it goes in. And you can see one of the things that we can show that's kind of cool is because we're using web animations, we can use the animations inspector in the dev tools here. And if we do that, it just sort of automatically slows it down. And you can kind of see there what's happening. And you can also, we're using the animate controller here to pause the animation when you click. And I can kind of this is just sort of, I don't know why you'd ever want to do this. It's just sort of, we're showing this in the example here that we're freezing the state. Cool. Now, how does that work? And what does that have to do with flip? Well, what we're doing here, and these are this card element and the detail element are actually different elements in the DOM. But what we've done is we've told our flipping technique in the animate directive to link up use this card as the starting position of the flip that's going to be this detail. And to do that, what we do is we give an ID to the animation to the animate directive that we want to sort of use as the source. And then this is the card. And then in the detail, this is the detail. And again, we give it an in ID that say, use this one as a reference. And then we do the flip also so that we can go backwards. And again, if you want to see the details, please check out the example on lit.dev because there's a little bit to it here. But the key concept is to be able to link up that ID and the in ID to create this sort of linking effect between the elements. Cool. So there we saw basically that, again, sort of just to emphasize here, the ID and NID link the two together so that we can synchronize and really show the relationship between the elements, which is one of the cool things that you can easily do, which otherwise would be a lot of boilerplate to set up. And again, it sort of did that spring effect with the on frames, which I didn't show, but you can check out the code if you want. Okay, so where are we with this package? Well, we're really happy, but it still has a few things to work on, and we're really looking to refine the API and get some feedback to make sure we're covering a bunch of sweet spots for the real sweet spot of the use cases that we want to hit. And specifically, again, we're sort of want to refine the API. We want to do a little bit better support for animating elements before removing them. There's some work in progress to make that better. More configuration around, better configuration around how the properties actually animate when you kind of want to use certain properties for flipping and not flipping. Maybe some built-in support for springs, and Justin has a PR for that, which I just have to review. Some timeline capabilities possibly for the animate controller. And then we're really kind of, there's a concept coming to web animations called scroll timeline, which may take a bit, but it's actually pretty simple to hook up to scrolling. So we may want to put that into the directive or provide an additional tool to do that because there's some cool effects that you can do pretty easily. Okay, and as a preview of some of the stuff that we're working on, I want to show just one more example really quickly, and that is this accordion. So this is actually turning off, this is very experimental right now. I have a version of this where I have an animate layout, which turns off the flipping so that for an accordion, you kind of just want to actually animate the height. And so basically, we've done that here. And it does that kind of cool effect. The other thing that this does is it actually hides the elements so that the elements that are not visible are actually hidden in the DOM, so there's no cost for them being there in terms of rendering. And again, we're sort of customizing the frames because that's a cool effect. So this is sort of just a preview of something that we're working on. And again, as I mentioned, it animates height directly without transform, which is a configuration option that we want to make available. And we probably want to make sure that we have good support for doing stuff like hiding and showing elements before and after the animation. So that's that. So What did we cover? Well, we covered the Lit Labs Mocha-Stream package, looked at some quick tips for using it effectively, dove into some examples, and really saw where we are on the roadmap. So that's all I have for today. And thank you, everyone. So there we go.
Thank you, Steve. And that wraps up our talks. I know we've been talking for quite a while, but considering all things considered, we're only over about 15 minutes beyond what we thought we might have been. And since it was 9 talks, could have been a lot worse. But you guys all asked a lot of very good questions, many of which we have addressed at least partially in the chat, but we do want to take some time now. So if you have any last questions to slide in, please go ahead and put them in the chat. Meanwhile, we've tried to flag some things that we want to talk a bit more about. So we will we'll bring a few up on screen momentarily. And I don't know, maybe someone can fill some time while I go scroll back through those comments to the ones that we've marked, because StreamYard is lovely, but it's not actually very good at letting us pull up questions from an hour ago.
Well, there's a good question that just popped up at the end, which might help you get going.
Which one?
The one about, yeah, I wish we could flag these. The one about task from 1145.
Ooh, yeah, I can take that. Yeah, we did actually thought of that.
Just really quickly, just go ahead and read the question out, even though it's there on screen, just to make sure.
So Nathan asks about task. Have you thought of adding cancellation, maybe via signal, as a second task function arg, so it can be passed easily to fetch and have an abort signal? So a little context on this is this will give you a way to cancel a task or a promise or a fetch using the abort controller. Yeah, we've thought about doing this. We haven't necessarily gotten around to putting it in, but we really wanted to gather feedback. We didn't want to start adding features that we weren't necessarily sure were necessary or that people even needed. So we have thought of that, but we don't want to, completely bloat tasks. So it's a good balancing act of how many features to add and keeping it simple and small. But I very much recommend or encourage you to go to the lit repo on GitHub and then go to the discussions page, and there should be a discussion specifically for task, and put your feedback there. And if people agree with it, vote on it, and it'll help us prioritize and add features to not just task, but any other project that was mentioned today.
Yeah, and for this also, the original task prototype did kind of accept and also generate automatically an abort signal for this. And this is exactly why the arguments to the task function don't come in as individual arguments. It comes in as an array. And that way we can add other options like abort signal as other arguments to the task function. So I think it's likely we'll get something like this.
All right, so we got another question up there. Someone want to go ahead and read it out and give a whack at answering that?
Oh yeah, I'll take that. Oh, and Gray, while you're at it, do you want to add Brian? I think we miss him on the Brady Bunch. I'll read the, okay. So the analyzer is designed for code generation, or is it designed as a replacement for lit analyzer with syntax checking and litting? So really good question. We are designing the Labs Analyzer package as a code analysis tool that can serve lots of different use cases. So we're starting, it kind of started out of this need for static analysis for the wrapper generators, but we're definitely designing it such that it can serve that sort of analysis piece of tools like a future version of the VS Code TypeScript language service, as well as the ESLint plugin. So right now, a lot of these tools that we have that have been kind of built up in the community tend to re-implement a lot of the logic that Lit does under the hood. So there's a chance that those get out of sync. And so the new analyzer is actually using the important code out of the client-side library to make sure that we're kind of doing everything across the ecosystem in the same way. So the TLDR is we're considering that as a use case for this new package. It will take a lot of time. There was a lot of work that was done to build the current generation of the of the VS Code plugin. So over time, we expect to get there and be able to kind of replace things out under the hood so that we're all using this common package. But for the time being, we're kind of focusing on first the wrapper generators and a new kind of custom elements manifest generator that will be maintained by the lit team.
Thank you, Kevin. We have another question. Are those decorators, are all those decorators are TypeScript decorators, right? Since decorators are now stage 3, how will this eventually work in Vanilla.js?
Yes, I think this was a question about the decorators I showed with context. Yeah, and this also applies to all the decorators in Lit, the app property decorator, add query, and whatnot. Yeah, so most of our decorators, I think we have to double check with context, work in Babel as well. So they're kind of hybrid TypeScript Babel decorators. And yeah, they are not yet upgraded to the new decorator stage 3 spec. We've been kind of waiting for TypeScript to implement. Babel's already implemented. There is now a PR for the TypeScript compiler to implement the stage 3 decorators. And then it turns out there's one more thing we need to wait for, which is metadata, so that the decorators can kind of contribute like the attribute name for a property, for instance. That's being kind of rapidly worked on right now. So, you know, we're just waiting for things to fall into place. I don't think we're rushing too much to adapt to the new standard before it's very usable. You know, until it's implemented in browsers, it doesn't actually give us a huge advantage over the ones that are just implemented in compilers. So as soon as we see the browsers move and implement this, which I hear rumors might be soon, next few quarters, then we'll jump on it. So we have a plan to get there. And I also think there's a chance that we might be able to make our decorators kind of backwards compatible and just work with all of the different specs. We'll see. We'll try to make that happen.
So basically, following closely, having a plan, influencing where we can. Yeah.
Here's a question about how the motion package compares to the shared element transition API, which is coming down the line. It's been talked about recently.
Yeah, I can take that. So I think that API is really exciting. We want to make sure that the motion package plays nicely with it. And, you know, it's a little bit too early to say because it's sort of work in progress, but we're looking into it, and we do want to make sure that it works well. Animate works cross-browser, and you can use it today. That transition API looks promising for the future.
Is there a good place to get Lit Swag? Not currently. We do have some cool Lit Swag that has sort of been produced for various reasons, especially some of our new YouTube series. But this is actually something come talk to us in the Discord chat if you're interested in Lit Swag, and let us know specifically what types of Lit Swag you might like, because I think there's probably enough good sort of on-demand sort of production options that we could look at. We could probably create a good Lit Swag storefront that way to start, and then maybe if we sell enough Lit Swag, then we can do larger runs of fancier stuff. But thank you. We'd love to have you guys wear and hang and drink from, and whatever else you want to do lit branded materials. So let's see, where's another good one.
There are a few new ones as well.
Yeah. Here's one about application level concepts. I don't know if someone wants to field that.
Yeah, so the question from Mark is, I'd love to hear more about anything on the application level concepts you had mentioned previously that you were investigating. This might refer to some talks we've given in the past, one I gave at a GDG fest in like 2018 or 19. I think in some ways we're seeing in labs like the fruits of some of these ideas already come forward, especially with like task and context. One package we didn't talk about today because it's kind of the most labsy and nascent of the labs packages is a router. We've been writing our own router a little bit. This is a very part-time package because it's like very small. We can use new browser APIs like URL pattern, and because it's built as reactive controllers, so it's very easy to plug into our elements. I think from there we have some ideas about, maybe how to do state loading. We have a bunch of libraries that the community has built that integrate with state management tools, and we're going to want to look at some point about plugging that in with SSR and things like that. So right now we're just kind of trying to make progress, I think, on SSR, context, task, and then router, and then we'll get to some new stuff after that. Yeah, no updates on anything new as of yet, though.
All right, and then Thomas had a question about context and specifically how it scales.
So I actually think that this is going to be okay. I think one thing people don't always know about how Polymer worked back in the day is that all of Polymer's two-way data binding, when it advertised property changes up the tree, used events. So events can be fast. I think Polymer did a bunch of tricks to make events faster, like reusing event objects. Events aren't a lot different than a function that walks up the tree and invokes some callbacks. But this is what I was hinting at when I said that in order to graduate, we need to do some benchmarking. Because especially if you're going to maybe try to use context for something like theming, where hopefully CSS and inheritance CSS properties can take care of everything. But if they can't, and you were going to use context in every single visual element in your app to consume theme values, we'd better make sure that this performs well enough. And so it could be that things are fine. It could be that we have some advice to give similar to React's context advice, where they say you can use context at kind of a coarse level granularity, but kind of caution not to overuse it. So we'll add some benchmarks and see how this plays out.
Yeah, I think the other thing I would just add quickly is we wouldn't expect this to ever really even be noticeable unless you're talking, context consumers in the thousands. In which case I refer you to Brendan's excellent discussion, as well as potential optimizations around stuff like using intersection observer to only do things when stuff is on screen. There's optimizations that we can use to potentially get around that if it ever does become an issue. But again, we want to do some benchmarking to really understand.
Yeah, so that segues actually nicely into, there are a couple of good virtualizer questions, which maybe Brendan and I can take a whack at answering next. And while I'm doing that, if any of the other folks on the team want to, do a trolling pass through the comments and make sure that we aren't missing any gems, you can queue those up. So this one is asking about defining a scroll target for a virtualizer. So that in previous versions of this body of work and in its predecessor, there actually was kind of an explicit API for defining a scroll target. The current version here will actually basic, what it needs to do. The DOM tree to find scrollable parents, if you will, and it will calculate the portion of itself that is visible, taking all that stuff into account. And it's possible that in like crazy nested cases, there are lurking bugs in there, but for right now, it's very nice because you don't need to really think about setting a scroll target if it will sort of do the right thing.
And there was another question about, yeah, there we go. About the table
question.
Oh, that's not the question. Same guy. It was a question on HTML tables. Yeah, that was right. I don't know. This might be a good opportunity for a table specific layout to handle possible tricks to size up in hidden table rows. I don't know if you've attacked that one before, Gray, but
yeah, going back, I think there are various ways. I mean, the short story here is that like natively in the browser, table layouts are sort of a special beast. And so sort of a general purpose virtualization mechanism, such as we have in Virtualizer, is going to not be super compatible with that. So you can totally use Virtualizer today for table-like things. And in fact, if you look at most virtual table solutions out there, you'll find that they don't actually use the semantic HTML table elements at all, or they use them and they completely redefine the styling in CSS so that you can then apply your general purpose, layout to it. So you can actually use either of those techniques in Virtualizer today. Like you can actually use the virtualize directive inside an actual table element, but the thing is you're going to need to do some CSS style resetting to enable the general purpose go to work. Or you can basically create non-semantic table markup and then go through the work of assigning the proper ARIA roles and stuff. And I think either of those is valid. One really cool thing is that like the most popular package for virtual tables in React has recently sort of its latest version. It's now I think called TanStack table instead of React table, and that's kind of a headless virtual table thing. And I'm pretty sure that Virtualizer as a low-level virtualization primitive will marry very nicely with that. And it's kind of on our list of things to kind of play around with, is just that integration, because I think that's been proven to work in a lot of projects, and it would actually be a great fit for Virtualizer. Okay, so let me check and see if anyone's queued up anything more. Am I seeing anyone want to nominate anything verbally here? Or
Yeah,
are we?
I think we have one from about 1017.
Oh my goodness.
in
Going
there.
way back
Yeah,
into
way
history.
up at the
Yes.
top.
Give me several minutes to scroll. Okay, 1017.
About context and modals. There we go. Okay. Yeah, how will context work with modals and portals? Yeah, so I think for us, one of the reasons why we chose a single context event name, which is called, I always forget the name because we've abstracted away so much. I think it's called context request, is so that you can do interesting things like reroute the context event, right? Like you can do the context pattern we do and just make up your own event names. But in the DOM, you can't listen for kind of wildcard event names. You have to listen for a specific event name. So because context puts all that stuff into one event name and then just gives the event a key to go off of, you can actually do things like the context root utility will buffer all the events that made it up to the root that didn't get handled by somebody. And if a new provider comes in, it'll replay those events so the new provider can provide them. Similarly, if you were trying to kind of teleport context events from one place in the DOM to another, you could have a listener that captures those events and then replays them in another DOM tree. So if you're doing stuff like rendering something outside of its DOM tree over to a portal technique, because we have the single event name, you could wire that stuff up. We haven't had a need for that. And I think Ben Dallaire, the author of the package, pointed out that as the browser gets things like dialogues and pop-up and stuff, maybe we won't need to move DOM around that much. But certainly I think we could support this in context. So like maybe a discussion comment in the feedback or an issue, and we could take a look at that.
All right, so with that, we are now at the little past the 2-hour mark. So I think let's go ahead and wrap this up. Thank you all for sticking with us. We've actually had amazing attendance throughout, and it's been great to see people here with us. Thanks to everyone for giving great talks, and we'll look forward to the next virtual event. In the meanwhile, come talk to us in Discord and GitHub discussions, and we'll see y'all later. Thanks, everyone.